This is your final review before your chapter, whatever chapter this is, on fractions, decimals, percents, grade 8. These are the questions that, upon looking at your actual test, you had concerns about how do I do these. So these questions are a great review for solidifying those parts of this test that you need a little bit of work on. So the first question is a true or false question. It says 0.75% of $120 is the same thing as or is equal to 0.075% of 120. So from the start of it, if I'm looking at this question and I'm saying, is this the same thing as this? It's like, maybe. They look like they should be the same because I know that 3/4 is 75. I know that that's a part of what it is. And 0.75%, I remember that this is actually less than 1%, because I remember that most people think that this is the same thing as 75%, but it's not. And this looks like less than 75%, so it could be true. But let's see how we solve it. So if I'm going to solve this, I have to just look at 0.75% properly. So 0.75% is the same thing as 0.75%. These two numbers are the same thing. Okay. This is 3/4. This is 3/4. This is a percent sign. This is a percent sign. So if I was rewriting that question properly, this is what it would look like. And clearly, this number and this number are not the same thing. So this is going to be significantly less in terms of percentage-wise than the first one. So the answer is false. They are not the same thing, right? And my advice to you is this: is if you have a fraction with a percent sign, just change the fraction to a decimal and just put your percent sign down with it, and that's just converting it to another way to think of that 0.75% as a decimal or as a fraction. The second question, and the one that's worth probably the most points, is a table that looks like this. You're given one of the three forms, and you're asked to give the other two. So if you're given a fraction, okay, any fraction you have on the test, the simplest thing you can do is just take your calculator and divide the numerator by the denominator, and you will always get the decimal form. All right, 0.875. And once you have it in decimal form, what that allows you to do is it allows you to write it as an equivalent fraction that will have a base 10 denominator. This denominator here is 8. And when I have a denominator of 8, it doesn't let me write it as percentages easily because a percent's out of 100. So in order for me to do that, I would have to rethink that as an equivalent fraction out of 100. And when it's 8, I'm not really smart. I can't think of what I multiply 8 by to get 100. So for that reason, it's best to first convert it to a decimal and then rethink of that decimal as a fraction with a base 10 denominator. In this case, because I know my place value, that's tenths, that's hundredths, that's thousandths, that decimal is really the same thing as 875 thousandths as a fraction. And once I have a denominator that's one of those base 10s, to get that to an equivalent fraction out of 100 is real simple, right? I can manipulate any fraction that has a 10, a 100, a 1,000, a 10,000, a 100,000, a million as a denominator and get it to an equivalent fraction out of 100 by dividing by a base 10 number. In this case, 1,000 divided by 10 is 10. 875 divided by 10 is 87.5. And once I have it in this form, because percents are right of 100, I could then write my percentage as being 87.5. So going back to my original part, if you had 7 out of 8 on a test, you would have achieved 87.5%. Okay. The second question, you're given the decimal this time, and you're asked to write it as a fraction and as a percentage. Well, when you're given a decimal, if you know your place value, you can always write it as a fraction, because when I look at this, this is the tenths, this is the hundredths, this is the thousandths. As a fraction, that is 8 thousandths. All right. Now on your test, you're probably asked to, it might say LTF, or I might say make sure you express your answers in lowest terms. And all you have to do here is just realize that you probably would start with 2 because you know that it's both even numbers. You divide both by 2, and you keep doing that process until you got it down to a fraction that you can't divide by 2. But I'm pretty bright. I know that 8 is a factor of both, and that 8 divided by 8 is 1, and 1,000 divided by 8 is 125. Okay, so in lowest terms, you could write that as 1 over 125. Again, the process, if you didn't know that, you could have just taken your 8 over 1,000, divided it by 2 to start. You would have got 4 out of 500. You're like, I can still divide by 2, so you divide by 2 again. You get 2 out of 250, and you're like, oh, I can still divide by 2, and you got 1 out of 125. Okay? The process would have been the same if you didn't use the greatest common factor that both share. And the last one, once you have this base 10 denominator of 8 over 1,000, I'll just write it over here. You can always create that equivalent fraction out of 100. In this case, I divide by 10 and I divide by 10. I get 0.8 out of 100, which means it's 0.8%. So again, if you got 8 out of 1,000 on a test, Mom's not going to be very happy with you. You scored less than 1%. You scored 0.8%. And another way to write this, we could write it like this, or we could actually even write it like this. This answer, and this answer all mean the exact same thing. They all mean 0.8%. They all mean less than 1%. And the last question of this section says 12 3/5%. My advice to everyone is, if you have a percent that contains a fraction, no matter what that fraction is, convert it right away to a decimal, right? Just think of that as a decimal instead. So my thought as a math teacher would be that this is the same thing as that. And the reason why I did that is because now I can think of it as being this. So 12 6/10% is the same thing as 12 3/5%, because 3/5 as a decimal is decimal 6. So 12 3/5 and 12 decimal 6 is the same thing. And the reason why I like to have it as a decimal instead of a fraction part is because now, because it's a percentage, I know that this is true as a percent, and it's 12 decimal 6 out of 100 would be 12 decimal 6%, which as an equivalent fraction is 126 over 1,000. Now the reason why I made an equivalent fraction is I don't want to have decimals in my numerator, so I had to multiply it just by a 10 because I only had to move it one place to create that. And then I'll come back to lowest terms in a second for that, but the reason why I go right to here is because now as a decimal, that's 126 thousandths, which as a decimal is 126,000. So just to go back in time, 12 3/5 and 12 3/5% and 12 decimal 6% are the same thing. 12 decimal 6% is this fraction, which is an equivalent fraction without a decimal in the numerator. Is that 126 thousandths looks like this as a decimal. Now again, you have to reduce this to lowest terms. So 126 and 1,000 both share 2 as a factor. So that would be 63 out of 500 if you remove 2 as a factor, which is lowest terms. Okay? So for those questions, there's a little bit of thinking, and the more you do them, the more you practice it, the more you understand place value, the more you understand the magnitude of numbers, the size of numbers, what this really means in terms of an amount of something. It starts to make a little bit more sense. But with the limited time we have practicing these questions, you have a limited understanding of them, and hopefully the more you practice them, the better you understand them, and the more you can use them later on. And the third question you had questions about was this one. I think it said solve it mentally. All right, so for this one, you can't use a calculator for it. You need to solve it mentally. So when you solve it mentally, there are certain percentages that you learned in grades 6 and grade 7 that you could find mentally. These being like the 4 big ones, and maybe 5% too. Maybe 5%. So 50% was simply half of the number. 25% was half of half, because if 50% was half the number, then 25% is half of 50%, or half of half. 10% we learned that we could just move the decimal one place. 1% we move the decimal 2 places. And 5% was simply half of 10%. All right? Those are what you learned last year. So the addition to this year is you learned 2 new ones. You learned 0.1%, actually 3 new ones. 0.5%, and something like percents larger than 100. So for 0.1%, the rule would be move the decimal 3 times, just like 10%, 1%, and 0.1%. The rule would just be move the decimal 3 times to find a tenth. 0.5% or 0.5%, it's half of 1%. And 200%, the rule would just be to double what you have, and that would be 200%. So with these new ones here, to find 10.5%, I'm going to use my old rule of 10%, and I'm going to use my new rule of 0.5%. I'm going to put those together. I'll get 10.5%. So 10% of 280, I move the decimal one place. 10% is $28. Now I have to find this 0.5%, but before I do that, over here on the side, I'm going to find 1%, which is move the decimal two place. 1% would be $2.80. And since I'm looking for 0.5%, if 1% is 280, then 0.5% would be $1.40. And when I add those together, I would get $29.40 as 10.5% of $280. Okay, so just thinking in terms of which ones do I know, and the sum of those make up whatever percent I'm looking at. So for 10.5% of $280, that's the pathway you need to do. You just need to find a 10% and a 0.5%, put them together, and you get 10.5% of whatever number you're looking for. The next question, I think, was mental math as well. I think so. Yeah, so this is solved mentally as well. So again, looking at this one, 35%, I can think of it as being this one plus this one, both of which I can find mentally. And this fraction, a 1/10 of a percent, we just talked about in the last question. A 1/10 of a percent is really the same thing. It's just the same thing. I'm just writing it a different way. So 25% is half of half. So 50% would be $400, and therefore 25% would be half of that, which is $200. 10%, I just move my decimal one place over. That's $80. And a 1/10 of a percent, we move it 3 times. So once, twice, 3 times, that would be 80 cents. So 25 plus 10 plus a 1/10 of a percent would be 35 and a 1/10 percent, which would be $280.80. Just add all 3 together. And I think the last one you asked for a review, or maybe the second last actually, second last, is if you were asked to express 3 3/4% on this grid, what would it look like? Well, pay close attention because it's kind of a trick question. What I was thinking people would do, and the reason why I asked this question, I shouldn't be divulging my secrets on this because I wanted to make you to make the mistake, is I thought people would do this. There's 1, there's 2, there's 3, and I don't know, roughly 3/4 there, right? So I would think that people would say 3 3/4% would look like that. But technically, that's not true at all, because 3 3/4% means if one of these squares represents 100%, one of something, or 100% of something, then 3 3/4%, booger. 3 3/4% would be, that's 1, 2, 3, and this one here I'm going to shade in approximately 3/4, and then I'm going to do one of these things. I'm going to magnify it, show 1/4 of that percent, 2/4 of that percent, 3/4 of that percent. So technically 3 3/4% using that grid would simply be 3 parts, which represents the 3%, and this partial of a percent, which represents the 3/4%. And technically, if we go back to that whole one that I did before, if I did all of this one, all of this one, all of this one, and 3/4 of this one, that would actually be 375%, right, if I did it that way. Because this is 100, this is 100, this is 100, this is 75%. All 3 of them would really represent 375%. So I wanted you to show that this and this are completely different things. And your last question is the compounded calculation question. When this textbook was written on Prince Edward Island and most of Canada, there was no such thing as an HST. An HST is a harmonized is milk. Harmonized sales tax. And what that meant was, what we have now is we have our provincial sales tax and our government sales tax, and it's combined into one tax, and then the government sorts it out later and they just divvy it up beforehand. But before that happened, we used to have a PST for provincial sales tax, which was what we would use to build our roads in Prince Edward Island. And then we had a GST, and you would calculate this first and this second, and then you would get your final bill. But now that that's no longer the case and we only have one tax, we very infrequently would use double taxes. So one of the situations the textbook wants you to be able to do is be able to realize that there are discounts, that you can have, and then on top of that, taxes. So a discount is a reduction in cost, and a tax is increasing in cost. So if I think of this question first, I'm going to first apply a 5.25% discount, which is the same thing as a 5.25% discount. And I'm going to figure out what that is. So 5.25% on the margin in your test, you would probably do something like this. I have to move the decimal 2 places to get rid of it, which means I have to multiply not by 10, but by 100. That would be your equivalent fraction, which means that that's 525 10,000. So if you're terrible at decimal places and you don't know your place value, just do these lines like I do. Count at tenths, hundredths, thousandths, 10,000ths. 525 has to end there, which means this position here, right here, needs a 0 to keep that 525 in the correct position. So this percent discount is really this calculation in a calculator. This represents 5.25% of $88,000. Take your calculator, go 5.25% of $88,000 is, so your discount, I'll make a note of it up here, you'll save $4,620 off the price of that car. So take your $88,000, subtract the discount they're going to give you, which is $4,620, and the cost of the car after your discount is now only going to be $83,380. What a bargain. But then the next part to that, so you have to make a note of that somewhere, keep it organized. So I would probably, if this was my test, say new price. I'm going to label it so that my teacher can follow my train of thought. New price after discount. And now I'm going to figure out the tax. So 10.5% of $83,380 to a calculator will be 10.5% of $83,380. That's going to be the tax. Take my calculator a second time. Go, what is 10.5% of $83,380? And that will tell you the tax is going to be this much tax. This is where it gets a little complicated. So you take your discounted car price, you add on to it the tax. So I'm going to add on to it the cost of the car. And your final price will be $92,134.90. Okay. Now that's the basic way of doing it. All right. Now I probably should have organized this a little better. But if it was my test, you guys all know that you can take your highlighter, highlight your final answer, right? And that way the teacher can find it pretty easy. But there is another way you could have done this. So 5.25% discount. If this is the cost of the car, which was $88,000, and I have 5.25% discount. So 5.25% discount. That means I am paying for 94.75% of the car. So instead of calculating the discount and subtracting it, what I could have done is said, since this is going to be what I'm going to pay for, because this is the discount, I'm going to pay for 94.75% because that's going to add up to be 100%. I could have simply taken my 88,000. I could have been 94. Oh, that's not 9. 94.75% of $88,000, and that would tell me that price right there, which was somewhere on my list, $83,380. That's the cost of the car after the discount. Now, if there's a 15, what was it again? 10.5% tax. So a 10.5% tax. So there's 100%, which is $83,380. That's 100% of the car's cost. And I'm going to add an additional 10.5%, and I don't know what this is. How do I figure out what that's going to be? How do I figure what the whole thing is going to be? Well, the whole thing is going to be 110.5%. So instead of calculating the 10.5% and adding it on to the 100%, I could simply do one step and calculate 110.5%. So 110.5% would be that much money. Of 110% would be 1 and 10.5%. That's 110.5% as a decimal. And when I do that, I get my final answer with only going to the calculator one time, as opposed to 2 steps. So some of you get that. Some of you can use that. Some of you understand this picture here, and you understand this picture here, and you could probably go to the calculator only 2 times if you needed to. Some of you need to go calculate that discount and subtract, calculate the tax and add. Both ways are acceptable. I don't judge, but be aware of both if you can.